In this tutorial, we will be looking at the functions of present value, future value, and payment, and when to use those different scenarios and how to use them in Excel. And we'll use this situation to guide us. Jenna is graduating from college this spring and has a goal to buy her first home in 10 years. She would like to save $60,000 as a 20% down payment for the purchase of the home. Jenna found a savings account with an annual interest rate of 2.5% and has $1,500 to use to open the account. Once she begins working full-time, she believes she can make payments of $375 per month toward her goal. Use the PV, FV, and PMT functions in Excel to help Jenna evaluate the reasonableness of her savings goal. So off to the left here, we have the different information given in the problem. She has a goal of saving $60,000 for her down payment. Her savings rate is 2.5%. She would like to save this in 10 years. Right now, she has $1,500 saved up to start the account, and she hopes to put away $375 per month. So looking first at present value. The present value function is useful if we want to kind of work backwards. If we know she has this goal of $60,000 and can make payments of $375 for monthly for 10 years at 2.5%, is this the correct present value or the money she needs right now to start the account? So let's take a look at that. So we're going to press equals PV. Excel is guessing I want to do the present value function, so I'll click on it. It opens my parentheses and takes me through the different parameters I need. First, I need to know the rate. The rate is 2.5%, and we'll divide that by 12 to convert it to a monthly rate. When I press comma, it advances me to NPER, which is the number of periods. She'll be saving for 10 years, and multiply that by the 12 monthly payments she'll make each of those 10 years. Advance over her payment. She plans to put $375 away per month. That is money coming out of her wallet. So that will be a negative $375, comma. And then these last two parameters are both in brackets. That means that it's not required in order for this function to work, but if we have that information, we will use it. We will never use type in this class, but we do have the future value available. We know that she, in the future, would like to have $60,000 saved up. So that is her future value, her FV. Close parentheses and hit enter. And what this tells us is that if she wants to save $60,000 in 10 years, by making $375 payments each month, she's going to need a future value, she'll need a present value. She'll need money right now that's up to almost $7,000. Notice this value is red, which denotes a negative, and negative means it's money coming out of her wallet. So right now, she doesn't have enough to complete that goal. She would need to increase her present value or the payments that she makes each month. Okay, for future value, we can go ahead and say, well, what's going to happen if she does use all of this information? Her present value, down payment that she has, the monthly saving goals she has at 2.5% for 10 years. What will that money grow to? So we'll say equals future value, open parentheses. The rate is 2.5%. We'll divide by 12 to convert it to a monthly rate. Comma, now we're on NPER, number of periods. That's 10 years times 12 months in each year. Comma, the payment she's planning on taking out of her wallet, $375 each month to put into the account. Comma, and then here, again, we have those brackets. We do have a present value available, so we will put it in that money is coming out of her wallet, that $1,500, and we'll ignore type. Close the parentheses and hit enter. So this tells us that if she starts with $1,500 and saves $375 a month for 10 years at 2.5% interest, she won't quite make it to her savings goal of $60,000. Okay, another thing we can do is calculate a payment. This is when we want to know what should the payment be. She has a goal of $375 as her monthly payment, but we can use the other parameters to help figure out what that payment should be in order to meet the goal. So equals PMT, and we have our function ready to go here. Again, starting with our rate, 2.5% divided by 12, comma, the number of periods, 10 years, times 12 each month, comma, present value, that's the money that she's starting the account with, and that's coming out of her wallet, so it's a negative $1,500. And then she does have a future value. In the future, she would like $60,000 in this account. So we'll click on that and close our parentheses. When we hit enter, we see that she needs to make a payment. Again, this shows as negative because it's money coming out of her wallet. So she needs to make a payment of $426.48 in order to meet that goal. Now, since we've done cell referencing on all of these formulas, we pointed and clicked to the different cells for information, we can come over here and play with it a little bit. So for example, if we increase her payment to $426.48, let's just round it to $427, notice what happens to her present value. It comes up to $1,400, which she does have available right now. So she could choose to start at $1,500 for her present value lump sum deposit and then just increase her monthly payments in order to meet the goal of $60,000.